Hi everyone, my name is Angelo Ramirez, and I am here to present to you my Capstone number 1 project as part of the M2M Tech Data Talent Program, cohort number 18. My Capstone project will focus on analyzing a dataset named Global Coffee Health. Note that this dataset contains synthetic records, meaning the records are reflecting real-world data but contain no actual personally identifiable information. Our next objective is to visualize the data via charts using Python and Boca. Next is to visualize the data in a world map using GeoJSON and Boca. Finally, we export our visualization to the internet using Netlify. All of these objectives will be coded using a Google Colab Python notebook, and in the notebook we will be using open source libraries such as Pandas for data manipulation and Boca for visualization. For an overview of our dataset, our global coffee health dataset came from a website named Kaggle, and the dataset consists of 10,000 records and 15 columns. Note that among all the columns, we see that the health issues column contains null values, which we will be cleaning later on. For a more specific description, we will take a look at how the dataset creator described the columns on the Kaggle website. Here we can see all the columns, but to be particular, we will be using the caffeine mg, which is the estimated daily caffeine intake in milligrams, and 1 cup represents 95 milligrams. We'll be also using the health issues category, which contains none, mild, moderate, and severe. Now for cleaning our data, we'll first disregard the last two columns named smoking and alcohol consumption, and we can accomplish this by calling the drop function in the data frame object and specifying the column names that we want to drop or remove. And here in our preview, by calling the head function and the tail function, we can see that the last two columns are not visible anymore. We can also confirm in the tail function that we indeed have 10,000 records on our data frame. And looking at the health issues column, we can see that there are null values shown as NaN. Now looking back at the health issues column, we can see that there are 4,059 non-null values, which means that it has 5,941 null values. And to fix this, we will fill the null values with a new value. In this case, we will fill it with a string that says no issues, and we'll use the fillNA function on the data frame column to accomplish our goal. And after running this function, we can see that we don't have null values anymore. One more helpful data frame function is the describe function. In here, after calling it, we can see all the statistical values such as the average, max values, and min values for each column that we have. We will be showing these values on the next slides. Now, our first visualization will be about the caffeine intake consumed by each individual based on their age. For the caffeine intake, since there are multiple records that belong to the same age, instead of showing one record, we will be showing the following data for each age. First is the average, which is the single number that represents a set of data, or best represents the set of data, the max value, the 25th percentile, and the 75th percentile. In our diagram here, we can see that the 25th percentile would be represented by the Q1 label, and the 75th percentile will be represented by the Q3 label. Here we can see the coding steps that I followed for showing our first figure for the caffeine intake by age. We first started by grouping the age column, Next is we created functions to calculate our percentiles. Next is we called aggregate function on the groups caffeine mg column, and then the aggregate function will create new data frames with the following columns shown here in the fourth step. After that, we define column data sources for each of the aggregate data, which means we will have column data source for the mean, the size, the max, and each of the percentiles. After that, we create a bokeh figure and add a line for each of the aggregate data. After that, we add in the tools like the hover tool and the crosshair tool, and then finally we show our figure. After following all those steps, we will see our figure will look like this one. In here, we step through the code in our Google Colab Python notebook, and I follow the same steps that I've shown earlier. So first, grouping by the age, creating the functions to calculate the percentiles, and then here we can see that we call the aggregate function on the group, and then we will, from the inside the aggregate function, we will call the mean, the size, the max, and the two new functions to calculate the percentiles. And we can see here that it created a new data frame as seen in this table. After that, we created a column data source for each of the aggregate data. So one for average, one for max, one for the each percentiles. And then here we create the figure, and then we create a line for each of the aggregate data, and then finally we add the tools and then show our figure. Just to show some of my observation, the maximum caffeine intake by an individual is in here. It is 718.3 milligrams consumed by an individual of age 50. And then we can see from ages 18 to 64 that the average caffeine intake is around 250 milligrams or 2.5 cups a day. And we can see the 25th percentile as well, that the lower 25% of our data consumes around less than 130 milligrams a day. And then if we look at our 75th percentile, we can see that the upper 25% consumes around 330 milligrams a day. And finally, after age 65, we can see that our chart here fluctuates or changes drastically. That is because our sample size gets smaller the higher the age goes. So for example, here in age 69, we only have a sample size of 2, while in age 72, we only have a sample size of 7. And so that's why we can see major difference of data starting from age 65 onwards. Moving on to our next data visualization, this time we will compare age groups and gender against the caffeine intake. Before it was for single ages, now to make things more simple, we will create an age group. So our goal here is to get the caffeine intake in milligrams consumed by each individual based on age and gender on each age group. And the age group will be determined by decade, as shown in the table on the right, where in the 30s group, the ages covered will be around 30 to 39 years old, and so on. The data will be grouped by age group, and then each age group will contain each unique gender. And in our dataset, we have male, female, and other. Since we are displaying less values on the x-axis compared to around 80 values on the previous visualization, this time we can show our data using vertical bars. Just to show how we form the age group, first we created a function that will return us the age group based on the age, and then we apply the function to the age column, and then afterwards we store it to a new column named age group. And in here, we can visualize the distribution of data using the pandas plot pie. And here we can see that the age group of 30s have the most data, while the 80s age group only has a sample size of 2. In here we can see the coding process that I followed to accomplish our goal of showing the age group and gender versus the caffeine intake. I won't be going through all of these since we don't have enough time, but in here we can see how I accomplished my goal. And after following these steps, we can see that our figure will look like this one. Now to step through the code, here we can see that first I created a list that contains the age groups, and then here's the function that I use to determine the age group based on the age supplied in the parameter. And after testing it, for example this one, I supplied 48, it will return the age group 40s. And after testing that the method works well, we can apply the method to the age column and then store all the data to a new column named age group. And in here we can see the visualization, the data distribution of each age group. And then in here we also created an array containing all the unique genders. Afterwards, we create a group for each gender and group them by age group. So in total we will have 3 groups. After that, we will call aggregate function to get the mean and the size of each gender group and store them in a data frame. In here also we can take a look at how I clean the data. Say for example, in the other the gender that has on the other category, like the gender type, it doesn't have data for the 70s age group and 80s age group, so I manually supplied 0 so that we can properly show our data. And in here I'm just organizing the data using a dictionary, and then in here we have a list that represents our x-axis. So for each age group we will have a corresponding gender. And finally, in here we will create our column data source, our bokeh figure, and the vertical bar. So in this first section we will be showing the gender count by age group as seen in here. And we can see that in the age group of 30 we have the most data, and then if we compare male versus female, they are almost the same, where the female is slightly higher. And then we can also see that we don't have enough sample size for the other age group. And then for the next figure, instead of using the sample size, we will use the mean or the average coffee intake. And in here we can see that on average everyone consumes less than 250 milligrams, starting from the teens to the 60s, and their averages are almost identical to each other. Moving on to our third visualization, it is almost identical to our previous one, but instead of gender we will be using health issues column. So our goal here is to get the caffeine intake consumed by each individual based on each health issue category on each age group. And Similar to the previous visualization, the age group will be determined by decade, and the data will be grouped by age group, and each age group will contain each unique health issue category, which are no issues, mild, moderate, and severe. And in the pie chart here, we can see the distribution of the health issue category, where we mostly have no issues as the most dominant category, and then we only have 17 records for severe. Following the same coding workflow or process that I used in the previous chart, we will see that the third chart will be looking like this one. So instead of gender, we will see the health issues on the bottom. And now stepping through our code, it would be almost similar to the previous one. In here, we show the data distribution for the health issues, and then in here we group by the age group, and we will have 4 groups here, and we will have a group for each of the health issue category, and then we call aggregate on each group, and then we clean up the missing data by supplying 0 on those age group that has missing data. And then here we create a dictionary just to be to make our code tidy, and then we create an age to health pairing dictionary to prepare our x-axis. And then finally in here we prepare our column data source, create the figure, add the vertical bar, and then add the tools, and then finally show our figure. And here are some of my observation. The severe health issue category does not have enough sample size, shown in here in red, and there's only 11 in the 50s age group and 6 in the 60s age group. From age groups 20s to 40s, those who consume more than 250 milligrams have mild to moderate health issues, as in here, while those who does not have health issues consumes around 200 milligrams to 250 milligrams. The difference in consumption of those with no health issues to those that have is only around 50 milligrams, which to me suggests that the coffee consumption might have less impact on one's health. However, just to have a safe measure, we can assume that it is advised to consume less than 250 milligrams based on this dataset. Our final visualization is based on getting the average caffeine intake consumed by each country, and we will visualize it using a world map. The world map will be shown using GeoJSON, and we will be getting the GeoJSON file from this source, HTTP GeoJSON maps. Shown on the right is how the world map will look like after importing the GeoJSON file and showing it to a bokeh plot. And our goal here is to change the color of the countries that has existing data and add a hover tool for more details. In here, we can have a quick look on the involved countries based on our data frame. When we group our data frame by country, we will see how many countries that we have data on. And after calling size on the group object, we can see that we only have 20 countries. This is why we should expect that a lot of gray areas in our visualization, because we are only highlighting 20 countries. And note that the UK and USA spellings are abbreviated. Now, in able to code this properly, we need to see how the JSON file looks like. So the world maps JSON file that we imported is a type of feature collection that contains the following layers. After opening the JSON file, here we can see the feature collection, and then we have a list of features here from 0 to 174, meaning we have 175 countries. And for each feature type, we will have these properties. So type, properties, and geometry. Geometry is used by Bokeh to draw the map in the Bokeh plot. We won't be modifying this one, but the important one is this one, the properties key. So this is a dictionary that contains all the properties, but really what we will be using is the name, so we can compare our JSON file to our data frame. And also we will be modifying this properties dictionary, so we can add the color, the ranking, and the average coffee consumption. Now moving on, this is how we determine the color based on the ranking. So to color our world map, we will be using the yellow color as a theme, and our goal is to change the color's darkness based on the country's ranking based on how much caffeine intake they have. Say for example, the higher the caffeine intake, the darker the yellow will be, and then the lower the caffeine intake, the lighter the yellow will be. We'll accomplish this by making a new function where it will take an amount parameter that will determine the color's darkness. And after testing the function, the colors will look like the ones shown below using the seaborn and its pot plot method. In here, we would, the lighter the color means this would be rank 20, and then going up, the darker the color, which means it will be rank first. Moving on, I will show you the steps that I took to accomplish our goal. I won't be going through each one of them, but this is how I coded so that I can show the map figure and highlighting all the countries in the figure which we have data on. After following all those steps, we can see the Bokeh plot will look like this one. And just to quickly step through our code, here is how I coded it. First, I imported the JSON file to a variable, and then here is how I tested that our JSON file works properly, and it indeed shows our world map nicely here. And then in here we group by country, and we can see that our data is distributed evenly, almost evenly, to all the countries, all the 20 countries that we have. Next is cleaning our data, which because in our data frame we have it abbreviated, while in the JSON file it is in full name. So in here we are just renaming USA and UK to their full names. And then after that, we will get the mean or the average of average coffee consumption of each country, sorted in ascending order. And in here we can see that Belgium will have the least average, while Spain will have the most average. In here is how we accomplish the color change. So based on the amount supplied, it will lighten or darken the color, as seen in this plot below. And then in here, after getting the function to work, we will add to our data frame a color column and a rank column. And in this part, we will modify the GeoJSON object so that we can see or confirm if we have matching data if we compare it to our data frame. And then in here, yes, we can confirm that all countries in our data frame exist in the GeoJSON file. And afterwards, after confirming that, we will add new properties like color, rank, and the average coffee consumption to the JSON properties. After modifying JSON properties, we will recreate our GeoJSON data source object. And then finally, we can use that object to show or create a figure and then show it just like this one. And in here, we can confirm that Spain is ranked number 1 as seen in the hover tool with an average of 247 milligrams. And then if we zoom in, we can see the Belgium will be ranked last or 20 with the average coffee consumption of 229 milligrams. Now that we are done with the last visualization, finally we will prepare our visualization for publish so we can post it on the internet and share the URL. In total, we have shown 5 Bokeh figures, and to show all these figures into one, we will use Bokeh's layout functionalities, and I reference the official user guide of Bokeh. So in here, so to know how to use the layout object, and then in the code here in the site, we can see that we included all the figures here in one layout object. And then after that, we will use Bokeh's output file to export the figures in an HTML file named index.html. And then the platform that we will be using to publish our web page is Netlify. And in here, after putting the HTML file to Netlify and publishing it, it generated a URL in here. If we go to the Netlify URL, we can see that our Bokeh plots are displayed in one page in here. So we have our gender count by age group and average coffee consumption by gender and age group. And then we have here the first figure with the average and the percentiles, and in here we can see the health status and age group versus the average coffee consumption, and finally we can see the world map that we have created. Just to show you all my analysis for each figure that I have already mentioned in the presentation, I have gathered them in here for my summary. And here are all the sources that I have used, starting from the dataset, the GeoJSON file, and all the coding help references that I used. This is where my presentation ends, and I hope this presentation gave you a better understanding on using pandas and Bokeh for analyzing and visualizing our Global Coffee Health Dataset. I would like to say a special thanks to all the instructors in M2M Tech for teaching us and sharing your knowledge in using pandas and Bokeh. Thank you for watching my presentation, and I wish everyone well. Thank you.